Hello. Hello, everyone. Good afternoon. I'm really nice and happy to see everyone here. And thank you for giving me 20 minutes of your time to hear me talk about API design. And I see more people are coming in, so yeah, I'll give them a minute. Sit down. Hi. Before we start, let me introduce myself. My name is Teresa. I'm a software engineer. I like the sound of DevOps, cloud engineering, agile, and cross-platform delivery. And some people here know, right? I talk a lot about Flutter in the past. I was like the efficiency of delivering and release of the software product. So today we're going to talk about API. I'm sure everyone here know what is API, right? Hands up if you don't. I'll target you, but audience, I'm joking. How many of you here are front-end engineers? Nice. Very good, very good. So we're going to talk about API today from the view of front-end engineers, right? And right, API, it used to communicate, right, from backend to front-end product. In a early stage, right, when you do web applications, usually it's the backend engineers, right? They just make some call to HTML page, upload it to a web browser. That's the old way of how you develop web app. And through along the way, you see the clear separation between backend and the front-end product. This is where we're starting to look at API design and why now it becomes a very important key element of our development life, and not just between backend and the front-end engineers, right? Even for backend engineers, they use API as well for between microservices or use library. So API design is actually really important. This is why we should design API as user experience, as a product, as a first-class citizen. And in my talk for today, I will talk about API design into two parts. First, we look at API design for your entire project. That means we will design the API, the URL structure, the versioning, pagination, the headers, the HTTP functions, right? And then I will talk about API design in a day-to-day feature delivery work and how API design works in your agile team. So let's look at the API design for your entire project. There are a few key points here, and those are the things once you set, you should just stick with it through the whole through your whole project. So first, URL structure. I'm sure you all know, right, all those points, but some of them might be forgotten. So I'm just going to mention it, right? So URL structure, make sure that you use noun instead of verb through the URL. For example, right, use images instead of get image. The only time you want to use a verb is from the HTTP method. For example, get, post, delete. And limit the URL to a certain length, right? Don't go over 2,000 of characters. And use queries instead of nested subdirectory. So, yeah. And make sure every time when you do any breaking changes, you communicate the change first, right? And every time when you make any breaking changes, you need to bump the API version. So this is what you need to consider when you look at the URL structure, the key point, right? So this is an example of what URL looks like. You have the scheme, and you have the top domain, like .com, .co.uk, or just .co. And you have the subdomain, and followed by directory. So usually the top level directory should be very stable, right? And then you have query separated by the question mark with values and some separator for more functions. So this will be your URL right? How it looks like in general. And second part here, for your entire, I keep saying entire, right? For your API design is the versioning, right? There are 4 ways you can version your API. So you can version it with query. It's quite easy to use, but it will be quite hard for you to root your API. Or you can use the API versioning embedded in the path. I'm sure this one is probably the most popular one that you probably use in your project. What it means is it allows you to use different version for different resource. So you can use API version 1 to get your marketing resource, and use API version 2 for payment resource. So this one is very flexible. So that's why maybe it's why it's very popular. And you can also do API versioning through content negotiation. And if you are using content negotiation, you can actually think about versioning it through content negotiation. The result is roughly the same as you would embed it in a URL. But if you're not using content negotiation, you might not want to use this one to version your API. And in the end, you can also version your API through the header, right? This one is quite nice and tidy. That means you don't need to clutter your URL with API. But the downside of this one is once you apply API versioning in the header, you might have to apply it everywhere in your service. So think about which versioning method you want to use. And the most important thing here is you pick one and just stick it in your project. Now, let's look at some of the request method. I'm sure you know all the function here. So get is a way to retrieve information. Post is what you need to create new content. And now let's look at put and patch. So imagine now you have your record, right? Your data in your database, and you want to make update for it. With the put, it allows you to update everything for one object. So let's say you have a user profile, right? The user has 10 fields. And for update the user with put, you update literally every single column for the user, even if nothing has changed. With patch, it allows you to specify just for update one entry. For example, right? I want to change the email address for user. With patch, I can just specify update the user with user email. So it's quite efficient. So I would recommend use patch for an update. And then you have delete, right? It just does what as it sounds to remove resource. And the search is a new released HTTP function. So it's a combination with get and post. It's a get with a body. It's a post without side effects. So it's actually a very safe way for you to do queries with search. And next thing, now after you have your structure, your versioning, and your function, right? Next thing you want to look at is the error handling and the status code. So you can use the established status code, like 100, 200, 300, right? For example, or you can come up with your own design, even to go a bit granular, how you want to do your status, right? So it's really up to you which way you want to go. But then, again, the key factor here is once you decide to use one set of code, and you give definition for that code, follow it through, right? The mistake that you could make here is to use a certain code for one service, and then use the same code, but give a different definition for a different service. You're going to confuse the consumer who is going to use API a lot if you don't follow it through. Also, for front-end engineers, we actually rely on the status code a lot to update our applications. So it's actually quite important, right? So we want to let the user know if the request is either success or failure, And also, when we look at the error, right, 400 to 500, those are the things we use to do monitoring, analyze, and we might use it to set our error budget. So here, actually, I would think this point is actually quite important in your API design process. So last part that you can look at to design your API for the project is either use pagination, filtering, or sorting. I know on one hand, right, you can say, I'm going to leave sorting, filtering to the application who will use my API. It's possible, but imagine if you have more than one product. If you have a mobile application, web app, desktop app, right, and depends on the framework they use, the sort result might come back differently. So actually, it's better, right, to push those logic functions to the server side, to centralize it, to have one source of truth, right? The golden rule here for development is push as much as you can in terms of logic to the backend side, and make sure that the front-end app is as dumb as possible. And the pagination is actually quite interesting part, right? Imagine if you are loading a list view in app, and you want to load, like, for example, 1,000 of records, right? But you don't want to load everything all together. Imagine the time and the resource. You need to load everything all together. That's why pagination comes in. You set a limit of how many records you want to load each time, right? If you want to implement an infinite scroll viewing feature, and you can load while the user is on the current page, right? You can start preload, prefetch the data from the next page to enhance a better user experience. So those are 5 key points, right, to look at when you design API for the project. And then after you design the API for the project, now we come to the day-to-day building the features, delivering the feature, and release the feature. This is where API first, the concept comes in. And what do we mean by API first, right? The concept is actually as a sound. We treat API as a first-class citizen. We treat API as a product. We treat API as contract. We think about API always before we code. And how does API first looks like in your day-to-day, right, in the Agile? So for example, if you're using Agile, right, in your sprint, right, in your delivery team. Let's say if we use Agile. First, right, before we kick off a feature, before the sprint starts, the product owner or the feature developer would have the epic ready, right? So we have an epic or a feature that we want to deliver for the sprint. And the next activity we do, right, is that we will do a story mapping or refinement or solutionalize, right, brainstorming, however you like to call this activity. So through story mapping, you would understand what you need to build for the feature and what the feature would contain to break a big piece of epic down into smaller pieces, right? Now, third step. This is actually very often ignored, right? I think in most cases, right, from at least my own experience, the third step here, for myself, I would receive API from the backend team saying, there you go, this API I create, now you can use it to create the features for your app. Is that the same case for everyone here? Yeah, I see people nodding, maybe, right? What should happen here if you use API first is that front-end engineer and the back-end engineer, you sit down together, have a meeting, and design API together. Not the overall structure of the API, but the JSON response of the API. Because imagine, right, we are the consumer of the API, we are using it. We should be part of the design together with backend team. Or that's why you hear often, right, the front-end engineers, right, they're mentioning, I want to use backend for front-end, I want to use GraphQL. Actually, the result is the same. We want to be part of the API design. as the key element here, designed together with backend team. After that, right, you can write some use cases, test cases, and document your API. So that will be roughly the flow of API first. And what do I mean by design API? So imagine now we have a story to deliver, which is to retrieve speaker information right in the events. When you sit down with the backend team in the beginning, this JSON response is empty. No one knows what to return and what to retrieve. And as front-end engineers, we actually talk with backend team to put all the details down together. Should we use integer here? Should that be a string? And should we combine 3 API call into one? What is the best way that we think can improve the user experience to improve the efficiency of the application? This is where you talk about it, right? Or even into detail, right? Do you want this key to be named in this way? Is the gender the best way to name the key? Or maybe I have a better suggestions, right? That's where you talk those things. So now we got our API design for the project. We got our JSON response for the feature. What's next? Okay, contract testing. I actually mentioned a bit of contract testing in my early talks. So what is contract testing? Don't mix this up with API test. They are actually a bit different, and I will explain you why. So contract testing is part of service testing, and it basically ensures all the services are communicated between each other. And it's faster than end-to-end tests because it doesn't use a real API on a mocked device, and it makes sure any breaking change in the API are captured early. And how does it work, right? So imagine now we have the testing, our testing plan, our testing structure, which can be a triangle shape or a square shape, or whichever shape your team decide to use, right? But make sure that your end-to-end test on the top is not very head-heavy, right? At the bottom, we always start with unit test, which should be roughly 85% of your entire test cases. Because unit test is cheap to run, and it's quite fast to run. You test the standalone functions, your component in the unit test, right? So that's why this should be roughly 85%-ish in your application. And then one level above it, that's the service test. It has acceptance tests, integration tests, and contract tests. So they should be roughly 15%-ish of the entire test cases. You should test happy path and unhappy path of your function. And on the top, the end-to-end test, this is actually very expensive, right? So I know some of you doing API test here to contact with a real server here, or doing a snapshot widget test, or integration right, on the UI level. So this one should be just happy path, which should form roughly 5% of your entire test cases. So contract test is in the middle part. And how does it work? I'll talk about this briefly. So I would recommend to use a library, a framework called the PACE, P-A-C-E. It's open source framework. If you use this framework for front-end engineers, right, to test your API, it's just not exactly, but similar as what you would do for any unit test. You would get an API and assert if the body contains some keywords you need, if the header contains some key element you need, if the status code return exactly the code you want. But what made contract test different from API test is in the middle, right, you see the broker. So the consumer side, the front-end side, once you run all your tests, right, you run it. If it fail, that means some of your tests is broken, right? But if it's success, everything is green, in the end, you will see a file is created. That's what the contract is created. It's in a JSON format. And the contract is uploaded in the middleman here. Broker is basically the broker will retrieve this contract generated from the front-end app. And then the backend team, they will make a mock request, but with a real API to verify the API has expected result uploaded by the front-end app. So in the middleman broker is the one that verifying the result and expected data. This is why contract test is efficient, right? That means if consumer side upload once, right, the test result to the broker, and anytime backend team made a change to the API, update it, or have new API created, it will go through, run the test with broker. If the test fail, the backend team will know my change will break the front-end app, and this is where they decide, okay, I'm not going to deploy the change. I will actually talk to the team, and we will work out this together. So yeah, that's my talk for today about API design. So you design API for your project, and then you design API response for each feature, and then you test it, right? So yeah, thanks for being here. I'm not sure.